This video is on decimal place value. Up until this point, students are familiar with the names and values of places for whole numbers. So for example, here we would have 123. So we have our hundreds place, our tens place, and our ones place, or sometimes called the units. And this 1 has a value of 100. The 2 has a value of 20, and the 3 has a value of 3. We want to discuss that the difference between place and value. Place is the location. Value is how much the digit is worth. So for example, this 2 is in the tens place, but its value is 20. So using that review and the knowledge that we have of place value with whole numbers, we want to apply it now to decimals. So we are going to learn about taking our decimal 3 places out from the decimal point. So the first thing we need to know are the names of our places. So this 4 is in the tenths place, and all of our decimal places do end with that THS. The 5 is in the hundredths place with that THS at the end. And our 6 is in the thousandths place with the THS at the end. So what we would say is we have a 4 in the tens place, but its value, it is worth 4 tenths. My 5 is in the hundredths place, but its value is 5 hundredths. And my 6 is in the thousands place, but its value is 6 thousandths. Now, if I wanted to say this number in word form, I would first say my whole number, just as I always would have said it, 123. When you come to a decimal point, we never want to say decimal, we never want to say point. When you come to the decimal point, you say and. So we say 123 and. Then we're going to read this number as if it was a whole number, 456. And then whatever place the last digit is in, you add that word to the end. So this number would be 123 and 456 thousandths. Okay, so let me give you another example that's a little bit different, that does not have any whole number. So we would just have this. Now I don't have a 0 here. I could place one. It doesn't change the value. Either format would be correct. So if I was going to read this decimal, I don't say and, because there is nothing that I'm combining my decimal with. There's no whole number that is combined with it. So you only really say and if you have a whole number. Otherwise, you don't reference the decimal at all. If I was going to say this number, I'd say 247 thousandths. If I have a number that is shorter, for example, I would just say 43 hundredths, because the 3 is in the hundredths place. Okay? So now let's talk about the different forms of these numbers. So what I mean, for example, with that is, let's say I have this number, and I wanted to put it in expanded form. This is currently standard. Word form would be how you would speak it. So this would be 2 and 632 thousandths. But let's say we wanted to put it in expanded form. There's really 2 ways of doing this. You can first do your expanded form based on value. So what we would do with that is take the value of each number and add those pieces together. So the value of the 2, it is worth 2, plus the value of the 6, that is worth 6 tenths. So I could either write 6 tenths as a decimal, or I could even do it as a fraction, plus my 3 is worth 3 hundredths. So that's going to be how I write 3 hundredths, plus 2 thousandths. And here's how I write 2 thousandths. So both of those would be expanded form based on value. If I had a 0 anywhere in my number, I would not include that in my expanded form because 0 does not have a value. So I would not say, plus 0/10 or anything like that. I would just skip over that completely. You could also do expanded form based on place. So you would write it as a 2 times 1 plus, and I'll explain where I'm getting these pieces from, 6 times 1/10 plus 3 times 1/100th plus 2 times 1,000th. So we would read this as I have a 2 in the ones place, plus a 6 in the tenths place, plus a 3 in the hundredths place, plus a 2 in the thousandths place. So any of these forms are acceptable for the expanded form of this decimal. And the last piece that we want to make sure we understand with place value, whether it's whole numbers or decimals, is that every one space over is either 10 times greater or 10 times smaller than the place next to it. So for example, if I'm moving to the left, my values are increasing. So this 1, even though it looks like it's the smallest number, it actually has the largest value because it's worth 100. So your values get larger the farther to the left. But this place is 10 times greater than this place directly next to it. Now, if I wanted to know how many times greater this place is than the 3, so those are 2 spaces apart. So every one space apart is 10 times greater. And a lot of times we make an error and say, well, 2 spaces apart would be 20. But this is all based on multiplying by 10. So 1 space is 10 times greater. 2 spaces would be 100 times greater. Same way, 3 spaces would be 1,000 times. So we would say this place is 10 times greater than this place. Or the hundreds place is 10 times greater than the ones place. Going in reverse, we could say, and I'll use the decimals, this 5 is 10 times less than the 4, the value of it, because it's 1 space apart, so that's where the 10 comes in, and because it's farther to the right, it has a smaller value. So values increase the farther to the left, values decrease the farther to the right, and every 1 space apart is 10 times greater. So every place is 10 times greater than the place to its right.